Hello everyone, my name is Lisco. Today I'm going to present about my single chip controller final project, which is the fruit type detection by color. So we are going to break down into a content overview with there is more. The first is introduction, second my purpose of my final projects, third is my project design, fourth is the Arduino code explanations, the fifth is project experiment, real life applications, comments and discussion and conclusions. So first, we start from introductions. So in the realm of technological innovation, the fusion of hardware and software has given rise to groundbreaking solutions. This kit bridged the gap between AI learning and tangible hardware, employing the ESP32 LOLIN D32 microcontrollers version and Arduino IDE for a single chip controller project. The goal is to create a user-friendly and affordable system for accurate fruit type detection, showcasing the efficiency and flexibility of the chosen microcontrollers. The project significantly extends beyond technical prowess, offering potential application in agriculture and food processing, enhancing the efficiency and fostering automations. So, what is my purpose for my project? So my purpose is to first develop a simple yet highly functional system capable of accurately identifying different types of fruits based on their unique characteristics. The second is to create an accessible and user-friendly solution by leveraging the efficiency and flexibility of the ESP32 LOLIN D32 microcontroller coupled with the Arduino IDE software. Third is to provide an affordable alternative for fruit type detection systems, contributing to the accessibility of advanced technological in various domains. And this is my project designs. Yeah, as you can see, this is the circuits and the project design of the real life circuits. And then the next is using the application, the FreeSync. And also be aware to put the same connection. And don't forget about the buzzer though, because the buzzer there is a positive and negative pin. So if you get it like upside down or the opposite side, it will not work sometimes. Next, we have the Arduino code. So these are my project consists of three files. The first is to train the fruits to train the object. The second is to train the neural network, and the third is the fruit detection, which is the application that is immediately will be used. So first we start from the training fruits. So in this code, it trains fruit with 5 different colors. So yeah, in my project, I use 5 different colors that will be continuously reading proximity and color data. When an object is close and the data collection is active, the color ratios are calculated and stored in the sensor data array. Data collection completes for each class, prompting the user to move the object away within a set time of frame. So I put it like 5 seconds and exported after the data collection is complete. It exported the data when all classes are already sampled, instructing the user to copy and save it as a text file. And in order for us to add like more classes or more fruits or more items, just modify the num classes variable and also reset the ESP32 for subsequent data collection sessions. So yeah, just press the reset if you want to collect another data. Yeah, this is my codes. As you can see, there is num classes 5 there. And this is the data collection. Okay. And now we are moving on to the training neural network. So in this part, the code trains the neural network for predicting the color of a fruit, aiding in the type of determinations. Input layer has 0 neurons based on input data dimensions without applying an activation function. Yeah, that is for the input layer. And I put 2 hidden layers. So the first hidden layer is using the dense or the fully connected with the 5 neurons and uses using rectified linear unit activations. And also the second one, I use the 10 neurons. Uh, yeah, I use the 10 neurons and use also the same rectifier linear unit activation. Sorry that I forgot to put it in these PowerPoints. And then for the epochs in training the node, I use 10,000. But what is epochs? Epochs in training the node, a complete pass through a data set. Determining the right number is crucial to avoid underfitting and overfitting. But there is something that is needed to note, that if you use too few of epochs, it may result in underfitting, lacking pattern to learn. So it will be hardly to identify what kind of fruit is this. But if we use it too much, it will be overfitting and memorizing the training data instead. So I just use 10,000, so just in case, for the neural network to train to be much better. And then this is the codes that I use. As you can see, in this part, you can see the train data equals to train data reader.read. I put all of the data set that I have been collected from the first session, the training fruits. I put the apple.txt, banana.txt, blueberry, kiwi, and orange. So it will let the neural network to access the file and train it. And then as you can see, I specified here the layer of input, first hidden layer and second hidden layer, and other output layer. I also put it there. And you can see I use the learning layer of 0.001 and epochs of 10,000. Yeah, this is another rest of my codes. Yep. Next, we move on to the final part, the final project, or the fruit detection. So in this code, it's the code for fruit detection using a pre-trained neural network with the set Wi-Fi credentials. The IFTTT URL provided for line notifications, continuous sensor data reading, and fruit type prediction when an object is close. Proximity sensor triggers data collection, color ratios process, and fed into pre-trained model. If a fruit is detected, a notification is sent to the line via IFTTT indicating the detected system. So in this project, I also use the IFTTT network. So when I scan the fruits, it can send the information into my line. So it will know that what kind of fruit is this that is sent to my line notifications. And then this is the code. As you can see, yeah, the notify line I used to send what is inside of my the code that is predicted what kind of fruit is this. And then are the rest of my codes. I have more explanations on how to do it on my YouTube channel. You can go check it out, or I will just maybe post it later. And next is my project experiment. Yeah, this is the after results of my experiment. As you can see, this is I do the reset button, so it to connects the Wi-Fi first to my line. And you will see from the serial monitor, and then you see detection start, and then you can start to detect it is an apple. It takes a little bit while to connect. Yeah, it takes a little bit while to connect and send the notifications to the line. And then as you see, I'm trying to detect another fruits. Yeah, here you see it's banana is written here in the serial monitor, and then this is the blueberry, and then this is the kiwi. Yeah, so as you can see, the line notifications takes a little bit longer to send. So yeah. And then what kind of real life application that I can use or implement my project? So first, we have four, I think. Yeah, I think I'm only thinking of four applications. So the first is quality control in the agriculture, because the first is the color-based ripeness assessment. So why do I think of that? Because by implementing the colors-based fruit detection system in agriculture enables precise ripeness assessment. Farmers can efficiently categorize the fruit based on their colors, ensuring optimal harvesting times and enhancing overall crop quality. The second is disease identifications. Unusual color variations can indicate the presence of disease. The system can be employed to identify such variations early on, allowing farmers to take preventive measures and mitigate the spread of disease in the orchards. And I also thinking of maybe automated sorting, because integration with automatic sorting mechanism enables automated categorization of fruits based on the color, streamlining post harvest processes and reducing manual labor. And then the second is inventory management. So I'm thinking of accurate stock monitoring and supply chain optimizations. So for accurate stock monitoring, maybe the fruit type detection system may aid in accurate monitoring of fruits inventory by precisely identify and cataloging fruits based on their colors. This also ensures an up-to-date and reliable inventory management system. Yeah. And then the second is the supply chain optimizations. By integrating the color-based fruit detection into the supply chain, distributors and retailers can optimize the transportation and storage of fruits, preventing spoilage and minimizing waste. How about educational tools? So yeah, for the educational tools, is the color-based learning. So the project serves as the educational tool to teach the students about color-based identification systems. Students may explore the principles of color recognition and its application in real-world scenarios, fostering the hands-on learning experience of AI algorithms or machine learning. Meanwhile, for the STEM education, the integration of ESP32 LOLIN D32 microcontrollers version and the Arduino IDE provides an engaging platform for students to delve into science, technology, engineering, and mathematics educations, particularly in the context of color-based AI learning, just as before. And then lastly, I'm thinking about consumer assistant. So you can use as a smart shopping assistant, like the consumers may benefit from the color-based fruit detection system for choosing the ripe and the freshness of the fruits. About the quality assurance, yeah, by detecting the color variations, it may indicate spoilage for suboptimal quality. The system contributes to qualify the assurance in the food supply chain, ensuring consumers receive the high quality produce. And then we are moving on to the comments discussion. Yeah. So in my doing of my project, I have encountered some kind of the problem. The first problem might be the limited feature recognition. The reliance on color sensing alone limits the system's ability to discern and intricate the details such as fruit shape and pattern, because my first main goal is to detect the fruits type detection. But since we only use like a limited component, so I can just use the color detection. Yeah, but I think you can still use it, but you have to train the data even more. Yeah, you have to train the data even more so it doesn't get almost the same color or the same type. And then second is the learning capabilities. While the project successfully identifies fruits based on the predefined color characteristics, incorporating machine learning algorithms could elevate the system's capability. And also lastly, the integration challenge. Yeah, I have faced so many challenges in this project. Originally, yeah, the project aimed to incorporate an or LED screen for enhanced user interface and information display. Was one of my goal, but the inability to assign separate pins prevents simultaneously use because of the library that I use. So maybe some future iterations may address this challenge and make it become better, and we can implement my project in the real life scenarios. And the conclusion? So, in summary, our fruit type detection project has successfully showcased the potential of integrating AI with hardware using the ESP32 LOLIN D32 microcontroller and the APDS9960, the color sensors, while also achieving accurate identification by color. Challenges in incorporating additional features like the OLED screen highlight areas that need to be improved. The project's real application in agriculture, inventory management, education, and consumer assistance underscore its relevance. Looking ahead, addressing identify limitations open the door to future enhancement and innovations in creating access efficient solution for diverse industries. Okay, that's it from my presentation. Thank you for watching.